Hello wonderful person, this is Anton, and today we're going to discuss some of the more unusual and more unexpected discoveries from the edge of the universe, and specifically discoveries from the James Webb Space Telescope that revealed several individual examples of ancient black holes that currently do not make a lot of sense. And specifically here we're talking about supermassive black holes that are millions and even billions of solar masses in mass, and that seem to exist when they should not exist yet. And that's because for many decades our understanding of these colossal black holes, and of course their host galaxies, was maybe just a little bit different. Previous models suggested that galaxies and black holes seem to generally grow together. In other words, they follow the process referred to as coevolution. A kind of a tight partnership, with the larger galaxy basically producing a larger black hole. And this is usually what we see around us as well. For example, some of the most massive galaxies known to us usually contain some of the most massive black holes. But in recent years, James Webb started to discover something a little bit different. Our previously carefully constructed understanding of the early universe started to be severely stressed. And that's because JWST was designed precisely to look back through space and time and to see some of these ancient objects that were previously invisible to everything else. And while what it has shown us so far suggests that a lot of these ancient black holes seem to be way more surprising than we thought. And so here we're finding structures that simply should not really exist so early. With one specific phenomenon we've discussed several times, referred to as little red dots. A completely new class of objects previously unknown to us that seems to represent some of these extreme giants. But I guess before we discuss more, let's actually talk about when all of this seems to be happening and why this is so important. And so if we look at this map of the universe produced by NASA, here we're literally talking about some of the first moments right after the period referred to as the Dark Ages. This is now the epoch of reionization, when the light from first stars and galaxies started to clear some of this early opaque hydrogen, allowing us to finally see certain things and certain types of starlight. And so this was when the universe was just a few 100 million years old and the galaxies just started to evolve. And so here, during this time, scientists discovered a bunch of these little red dots, which are now believed to be active galactic nuclei, or essentially active massive black holes, that seem to exist in many different locations all over the place. As a matter of fact, at least a third of all objects that were active at this time seem to be one of these little red dots. But unlike other galaxies, they looked a little bit different. They were all very compact, just a few light years across, and seemed to create a lot of this red light, all resembling massive red stars. We've discussed this phenomenon in some of the previous videos in the description, but today it's believed that there seems to be a black hole in the center, and possibly huge amounts of gas around this black hole, that then starts to fluoresce as a result of various emissions. But in this video we're not going to be discussing the little red dots as much as very specific examples that seem to be even more bizarre than what we see here. So all of this brings us to the first major discovery. The discovery that provided evidence settling the debate about the origin of these little red dots. And it's an object that's literally this. This is probably one of the most famous little red dots now, and it's simply known as QSO-1, or the more officially known as Abell 2744-QSO-1. This is at a redshift of 7, or when the universe was about 700 million years old. But as you can see from this image, this is a special object, because it's gravitationally lensed. Its true emissions are dramatically magnified because of a massive cluster between this object and us, and that allows scientists to see this much more clear. And so by using JWST and by using these gravitationally lensed observations, researchers were able to perform the first direct dynamical measurement of this object, specifically measuring the rotation inside the object in order to find out how fast things are spinning and what's actually spinning as well. And so this was no longer just a measurement based on luminosity and different types of spectra, this was now a measurement of spinning things. And so here the results strongly support a black hole interpretation. This was reported in a study you can find in the description, but in essence by measuring the motion of gas around this object, researchers realized it can only be explained by gas rotating around a very massive central point, approximately 50 million solar masses in mass. And that's already pretty massive. But it wasn't even the mass that was surprising. Here the analysis showed that the gravitational pull was actually only dominated by the black hole. Or just to rephrase this, there seemed to be practically almost nothing else there except for the black hole itself. No galaxy, possibly almost no stars, and very little gas. Which now implies that QSO-1 is potentially the most naked massive black hole ever discovered. Naked in a sense that it doesn't seem to have anything around it, except for that gas that's producing the emissions, with the current estimate suggesting that the mass of the black hole is at least twice as massive as everything else around this object, which is practically the opposite to what we observe in most galaxies today, with the evidence in this case essentially confirming that a lot of these little red dots are potentially something very similar. But it also suggests something really important. Black holes potentially form and grow much faster and much earlier than galaxies, and thus were some of the first objects in the entire universe. And that's not exactly what the scientists believed before. And so here the discovery is going to lead to some major recalculations and reassessments. Then we have our second discovery, another bizarre black hole that's even farther away. This is the object you see in this picture, referred to as GHZ2. Here the redshift is 12.34, or basically the light took approximately 13.4 billion years to reach us. The universe was only 350 million years old. And so while previous objects proved that these overmassive black holes seem to exist, this new discovery pushes the boundary even more. If this object is eventually confirmed and if the distances are recalculated and match current results, it would make it the most distant supermassive black hole ever discovered anywhere. And well, the reason this object stood out was because of its light spectrum. It seemed to contain extremely strong, highly ionized emission lines, and specifically the line referred to as carbon-4. This is a carbon atom that lost 3 of its electrons. And well, to remove these 3 electrons, you require something super powerful. Lots of radiation coming from something, which is extremely difficult to achieve through just star formation and through supernova. You need to have something even more powerful. And so based on sophisticated modeling, researchers realized it can definitely not be any kind of a star-like object. To account for these observations, this had to be produced by an active galactic nucleus, or once again, a supermassive black hole. And in this case, a black hole that's maybe about 16 million solar masses, or 4 times more massive than the black hole in the middle of the Milky Way, which by itself is absolutely ridiculous because this is literally just the beginning of galactic formation, and yet here we already have this really massive giant that's already producing so many powerful emissions. And though this discovery could have been a fluke and may turn out to be much closer to us, we actually have a second discovery from almost as far away. In this case, it's referred to as Nahks LRD Z8.6. The redshift of 8.6, or 570 million years following the Big Bang. But in this case it's even more massive, 100 million solar masses, or approximately 8 times more massive than the previous object. And this is also some kind of an overmassive black hole that should not really exist so early. And so this object, that's also considered to be a little red dot, seems to produce a lot of ionized gas emissions from some kind of a central accreting object. But the mass of this black hole really makes no sense. There is no way this black hole could have formed so massive by just consuming stellar mass, which of course challenges modern black hole formation theories. But we also know that overall this object appears to be pretty young, because it doesn't contain a lot of heavy elements indicating early evolutionary phase. And so overall the discovery of this object is actually an even bigger mystery because we have no idea how it formed. But because scientists discovered black holes that are in billions of solar masses in some of the closer locations, it implies that quite a lot of these ultramassive black holes possibly started from something very similar to this. In other words, this might represent the beginning of many different ultramassive black holes, and so by studying this object, we may finally understand how they form. At the moment though, this definitely makes no sense and is kind of difficult to explain. Although right now scientists explain this as maybe something like this. We have a really massive black hole in the middle and a lot of very dense clouds and stellar formation regions orbiting around the black hole in a relatively close proximity. So basically this entire galaxy is very compact and seems to mostly contain the black hole in the center. But in a nutshell, all of these discoveries present a profound challenge for previous models trying to explain cosmic evolution. Mostly because in a lot of modern galaxies and in the local universe, black hole mass is always proportional to the stellar mass of every host galaxy. And so finding black holes that seem to dominate everything is completely unexpected. And because we've seen several objects like this now, it suggests that during the early universe, black hole growth somehow outpaced the growth of everything else in the universe, sort of implying that this whole period was not just the Dark Ages, it was the Black Hole Age. The age when black holes seemed to be dominant, and stars and galaxies were only just forming. And well, today this is referred to as the overmassive black hole problem. The problem of not understanding how these very massive objects managed to form so early and how they essentially all started. but there are obviously at least a couple of propositions trying to explain this. For example, the light seed model. Maybe this all started with some of the primordial population 3 stars suddenly collapsing, with the black hole then becoming extremely voracious and essentially consuming a lot of mass for hundreds of millions of years. This would involve several periods of super Eddington accretion, which is usually driven by the magnetic fields, and would cause the black hole to become ridiculously bright and ridiculously powerful. But right now there is no evidence for any of this, so we don't really know if this is true, with the alternative explanation referred to as the heavy seed model. Basically, these black holes started large. They were born with about 10,000 to even a million solar masses in mass, very likely as a result of some kind of a really massive collapse when the universe was super hot and basically just contained a lot of very hot plasma. And right now this is the preferred explanation because objects like QSO1 and even this object right here seem to have already been massive long enough to not have been the result of some kind of a smaller star consuming mass. So essentially these black holes might have existed right from the start of the universe, and probably formed either through a direct collapse of huge amounts of gas, or were formed by tiny deviations in space-time during the first second of Big Bang, when some of these deviations collapsed into black holes. But in reality, we're not going to know for quite some time until more similar objects are discovered, or until we find something even farther away that shows us some kind of an evolutionary process. And so essentially if we find an even farther object that seems to be a little bit smaller and a little bit less bright, it might help us link the evolution here, explaining how these objects grew over time. But the main importance of these discoveries is the fact that they are providing extremely stringent observational constraints on the overall cosmic evolution, basically forcing us to rethink certain timelines and certain mechanisms of structure formation in the early universe. And that's because previous simulations seem to fail to replicate any of these objects at such an early time. And so we definitely need new models and new explanations. But additionally, the presence of these black hole primacies, or objects where black holes dominate all of the mass, fundamentally shift our understanding of the relationship between black holes and galaxies, and basically suggesting that it was probably black holes that were the powerful engines behind some of the first growth in early galaxies, and eventually set the stage for everything else to evolve over time. But this is at least based on some of the recent observations and some of the recent analysis. All of these discoveries are kind of new, and we've only started to observe these objects for the last few months, and so some of these explanations might change in the future. But once we have additional observations from maybe other telescopes, such as the Atacama Large Millimeter Array, we might be able to see something else that was invisible to the James Webb, something that could provide additional explanations. And so here, the observations of these tiny blobs of red light, literally stretching the limits of our detection capabilities, force us to rethink some of the history of the universe itself. Which means that we'll definitely come back and discuss this more once there are some additional updates. Until then, check out previous videos in the description. Thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. You can also support this channel by buying a Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.